Hello everyone and welcome to the Mathematiker channel. Let p be a prime number. We would like to prove that the square root of p is an irrational number. Irrational numbers are real numbers which are not rational, which mean that they do not belong to the set of rational numbers. So the question that comes to mind is, what's a rational number? Well, rational numbers are numbers that can be written as fraction, which mean, as a ratio between two integers. So, if x is a rational number, then there would be two integer numbers, a and b, with b different from 0, such that x is equal to the ratio a over b. Furthermore, we know that every fraction can be written as an irreducible fraction, which mean that, for every integer numbers a and b, with b different from 0, there are two coprime integer numbers, a prime and b prime, with b prime different from 0 such that the ratio a over b is equal to the ratio a prime over b prime. So according to this last assertion, for every rational number x, there are two coprime integers, a and b, with b different from 0, such that x equals a over b. So, if the square root of p was a rational number, there would be two coprime integers, a and b, with b different from 0, such that the square root of p would be equal to a over b. But that's exactly the question we ask. Are there coprime integers a and b for which square root of p would be equal to a over b? Well, let's suppose that indeed, there are two coprime integers a and b, such that the square root of p is equal to a over b. Then, we would have p equals a square over b square. And this means that a square equals p multiplied by b square. So, p divides the square of a, which mean that p divides a. Let's bear this result in mind and write it aside. From this last assertion, and by replacing a by p multiplied by a prime such that a prime is an integer number, as a is multiple of p, we would have p multiplied by a prime, all square equals p multiplied by b square. When we simplify this equality, we would have b square equals p multiplied by a prime square. So, p divides the square of b, which mean that p divides b. Let's also write this result aside. Now, when we started developing our hypothesis, we assumed that a and b were coprime, and this contradicts the results we found during our deduction. We therefore deduce that there are no coprime integers a and b such that the square root of p equals a over b. And this allows us to conclude that the square root of p is an irrational number. Thanks for watching the video, and please don't forget to subscribe if you hadn't already, and thumbs up and activate the notifications button for future publications.